and Learning Academy's one-week faculty development program on smart cities, organized by Department of Civil Engineering, Government Engineering College, Bilaspur. I am overjoyed to take this opportunity to introduce our resource person of this session, Dr. Ajay Singh Raghuvanshi. He is currently working as the head of department in Electronics and Communication Engineering Department at NIT Raipur. He obtained his PhD degree from the Department of Electronics and Communication Engineering at Motilal Nehru National Institute of Technology, Allahabad, India in 2012. He taught in College of Science and Technology, Bhutan from 1993 till 2007. His research interests are in the area of artificial intelligence, machine learning based approach in data aggregation and Internet of Things. He taught in IIIT Allahabad from 2010 till 2013. Till date, he has more than 50 research publications in different journals and conferences. He will be discussing on topic telecom facilities and infrastructure needed in smart cities. I welcome Dr. Ajay Singh Raghuvanshi for his address. Please, sir.
Thank you. Thank you very much. And we'll start with today's discussion on telecom facilities and infrastructure needed in smart cities. So as I have seen the audience, most of the audience happens to be outside electronics and communication department. So what I have tried to do is what I have done is actually this slide is. What I have done is I have put some understanding of telecommunication first, then telecom facilities and infrastructure, how we differentiate between facilities and infrastructure, then understanding the concept of smart cities, then telecommunication facilities and infrastructure that is needed in smart cities, then machine to machine, which is M2M and IoT for smart cities, and present state of telecom infrastructure in India, whether we are ready for smart cities, then future telecom infrastructure needed. So this is how I put my entire 2-hour session. So we start with the first one, and that is understanding telecommunication. And anywhere, if my screen gets frozen or there is some problem with the audio, please let me know, because for me it's not. I will not be able to understand whether you are getting it or not. So in between you can interrupt me.
Yes, sir.
But if everything is running properly, then avoid interrupting. Okay, thank you. So we start with the understanding of the telecommunication. So first of all, what exactly is telecommunication? So tele stands for Greek is long, very long. So long distance here basically. So tele is a long distance, and telecommunication is long distance communication, where you have to send information globally. That means from any point in the globe to any other point in the globe, the distance can be as large as that. So telecommunication is basically long distance communication. So that is telecommunication. And here we have a general model of telecommunication. We have transmitter and receiver, because communication can only happen between, and this is a generalized model which can be put to any system. Even for the human communication, we can have the similar model. I can give you an analogy how we can say for human also. But let's first understand the system. So we have a transmitter, we have a receiver, in between we have a channel. So like if it's a human, the transmitter is one human, and we have say audio talking, two people are talking to each other. So the information source is one human, and he's talking, so his vocal cords are the transmitter. The media is the wireless, which is air in between, where the things goes in longitudinal waves from one's mouth to other's ear, and from others' mouth to others' ear. So that is the thing. But in when it comes for long distance electrical communication or electronic communication, then we have a transmitter which composed of a source coder. Source coder is basically making information understandable to the transmitter, so that you can think as a source coder, or it is compressing. There's so many things which can be done with the source coder. Then we have a channel coder. Channel coder makes the information ready to be transmitted over the channel. Then we have a modulator. Modulator will, because since say if it is an audio system, audio has a fixed frequency, but all all different signals cannot use the same frequency. So we have to translate those information signals to some high frequency signals, and that is done with the help of modulation. And nowadays most of these are digital we can use the digital electronics. So then we are having a D2A converter, which is basically your digital to analog converter. Once we get the signals, that is from our this whole thing becomes a signal, we transmit on a channel. Now this channel can be audio, it can be simple wireless, it can be a fiber optical fiber, it can be a copper wire, it can be a underground cable, it can be an undersea cable, or anything. And normally this channel provider is the infrastructure. So infrastructure is basically, because channels, although we think they say wireless channel is free of cost, no. The channels are the most expensive thing for communication, because entire resource along the channel need to be associated with it. So channels are normally don't belong to individuals. Nowadays it's possible to have some small channels for you, but it is not possible to have entirely devoted channel, because it first of all is length is very high. It can be few thousand kilometers. The other is it is a national property, so that's why you have these spectrums being sold and given to different people. So that is the allocation of the channel. That's basically the channel allocation. And then this channel connects your transmitter and receiver together. So once the signal is on the channel, then it is open to distortions, noise, and so we have the design system to go against them, and then we get back the signal at the receiver end, and we we get the at the receiver end. Once we get it at the receiver end, we get the information back. So whatever information we transmitted, we try to get exactly the same information at the receiver end. Then types of communication. So in general, this is from just service point of view. That means when we are talking about facilities, telecom facilities, then from service point of view, what are the different types of communication? So in general, from service point of view, we can have three types of communication. And the point which is important here is privacy. So first is your point-to-point communication, and we call it as private communication. Wherever you have a communication taking place between 2 points, so one transmitter, one receiver, then this is called point-to-point communication. And point-to-point communication is also called private communication. So examples for point-to-point communications are telegraph, which is very old, now most people don't use. You have telephone, which is here it is PSTN telephone, that is the exchange telephone, which can be your between wired or wireless. Then you have cell phones, your mobile phones that you have in your pockets. Then you have emails. Emails are also private communication, where no one else is supposed to read your mails. So it is a private kind of communication. Then you have VoIP, that is voice on internet, or other way we can say internet telephony. So that is also private communication. And in private communication, the privacy of the signals need to be preserved. That means no one else should be able to know the signal. So most of the time the end-to-end encrypted messaging is done. But this doesn't mean that we can use it is no one can read it, because those who are providing you communication, they can always read what you are sending or what you are generating. So, but it, from the privacy point of view, in private communication, the privacy is one of the most important factors that need to be preserved. So end-to-end encryption, encrypted messages are normally used for P2P. So you have private chat over social networks, even on WhatsApp, when you are sending from your mail to somebody else, or from your account to someone's account, other than if you're sending it on a group, then it is supposed to be private. Nobody else should be able to know what exactly you sent from your account to others. So this, all this comes under P2P or point-to-point communication, or uh, private communication. So you have private chat on the social network. Then we have FTTH, which is fiber to home. There's also point-to-point. So the second form of communication that we have, or the second kind of facilities that we normally provide from telecommunication sector, is point to many selected point. One point to many selected point. Now here it is group communication, and we call it, in the technical name is multicast communication, where you are sending the same information to a group of people at a time. So point to many selected points, so that is multicast communication. So the group of the communication, so example is your, as you form small groups on WhatsApp, on Facebook, or any social medium, you form a closer net group like your old school friends, or maybe a class, your class candidates, or for a teacher to class, a kind of group is formed where all the information which is transmitted from one side, and like right now what we are doing, we are actually using a multicast communication, where whatever I am sending is being it is given to all those people who are part of that group. Nobody else get that information other than this selected group. So that's why from one point to many selected points. The selected points are, because this has to be mutually agreed points. So that is your multicast communication. Then we have a third type of communication, which mostly we use also lots, and that is called point to all, point to all points, or point to all. Point to all means from one place to all other points. Your first and to point and point to many, their privacy is important, and it is mostly two-sided. That means it is full-way duplex. When you say point to many or point to point, they are full-way duplex, where both the parties can communicate with each other at the same time. But point to all, which is broadcasting, it is normally one way. That means it will be always from a transmitter to many receivers. So that is broadcasting. Any multimedia that you have is actually using broadcasting, or it's called the broadcast communication. So example for that is your radios, which is AM, FM radio, your television, cable TV, DTH, that to home, and any mass media communication, they come under broadcast communication. So these, and so facilities also depend upon these three types of facilities which need to be provided by telecommunication. Then these are the facilities which are normally provided, and they can fall into different types of communication. Like first facility that normally communication provide is telegraph, which is long distance text messaging. It has now become obsolete. Anyone hardly uses it. But there was a time when this was one of the most used long distance text communication. Then we have radio, which is AM, FM, Again, it is also AM. Previously, AM radio was very important. It was everything. Now in India, actually in our rural India, still radios are very important. But in city, normally it is FM, which is more dominating in cities. But in rural, both AM and FM are still used. Then we have telephones, which is wired, wireless. You have from exchanges it is provided. The still people use wired telephones. You have then you have television. In television, you have broadcast television, which is there in our rural India. Still, many people they still see the broadcast DD1, DD2, DD3, and so many DDs are there now. DD news. Then you have DTS, direct to home, where you put a disc. Then you have cable TV, where a cable TV service provider provides connection to all the people. And so these are television facilities. Then you have cell phone. In cell phone, right now we have 5 generations, and the sixth one is there on the board to be developed. Sixth one is still there, still under, we can say it is under research and it is slowly being developed. But 5G is supposed to be developed, but it has not yet come completely. It was 2020 was supposed to be the year for 5G, but because of this COVID and other things, it got little delayed. But it has the technology is already out. Well, now infrastructure is coming up. Even in India, 5G infrastructure is coming up slowly. 4G is already all out. It is being used very intensively. 3G are the mobiles that you have old mobiles. 1G is obsolete, 2G is obsolete, but 3G, 4G, and 5G and 6G is coming up. That is for cell phones. Your phone becomes smart once 3G came. From 3G onwards, the phones that you have are smartphones. Then 4G was smarter phones, 5G is still more smartphones. Actually, smartness here of devices is how good ICT, that is your information communication technology, ICT is being used, that makes the things more smart. Or then you have satellite phones and satellite communication. Actually, satellite phones, they were supposed, but because of the development in cell phone, satellite phones didn't grow that good. But satellite communication is still being used for long haul communication, and it will remain there because we need very bigger and bigger bandwidths for more and more application. So satellite communication, where you put the satellite and that is used as a link. Then you have optical fiber communication. Now it has become the backbone of all the communication. So optical fiber themselves don't, they help in communicating. So the backbone is optical fiber. Then the data communication. Then we have data communication. Now data communication is basically computer to computer communication, or we can say the networks. So in data communication networks, we have the network which is very close to human. We have BAN, which is body area network, where the sensors can be born on the body and they wirelessly create a network. Then after BAN, hello, am I audible?
Yes, sir.
No, there is some disturbance. Somebody is in between interrupting. Anyway, uh, we have body area network. Then we have personal area networks. Body area networks are basically within the space of the human body. So you have some sensors which you can wear around, and these sensors can form a network, and they communicate with each other. Then we have PAN, which is personal area network, where you have this Bluetooth and other devices, which you can say the limit for this is around 10 meters inside one room. You have all your devices and they can communicate with each other. So it's around 10 meters. So that is your Bluetooth, you have low power LAN, you have so many other Zigbee and many technologies are there which are used in personal area network. Then we have LAN, which is local area network, which is for institution or for area, a campus or some bigger areas. Then we have a wide area network, which is in before wide area network there is something called MAN or metropolis area network, which is for a city or for a town. Then wide area network is normally for a country or for a bigger state or a bigger country. We have wide area network, and then we have global area network, which covers the entire globe. Then we have internet. Internet is basically network of networks, and then there is WLAN, which is wireless LAN. Because we will see why I put wireless LAN separately. The reason is we want wireless access. So for wireless access network, WLAN is one of the winner technology, or we call it as Wi-Fi. So these are the facilities which are expected from telecom to be delivered. Then infrastructure, what exactly is telecom infrastructure? As I told you earlier, the infrastructure is basically the medium through which the signals and data traffic flows. It is responsible for transmitting bit stream over the physical medium called channel. So the channel that actually forms the infrastructure, but to provide that, so what infrastructure that talks about telecom is it defines its electrical, timing, and their interface by which information is sent and signal over the channel. So all the characteristics, the important characteristics of physical characteristics, the electrical characteristics, and the timing characteristics are defined by the infrastructure. So example of infrastructures are like telephone wires. If you remember, if those of us from our generation will see a lot of wires when you used to travel with the railway line. You across with the line, you will always see a lot of telephone wires. Nowadays, you don't see them because we have many other wireless ways as well as underground ways to get the infrastructure. But previously it was telephone wires, which was one infrastructure. Then you have telephone cables. Cables are still used, both copper cable as well as optical cable. Optical cables, but optical cables are normally more used. And in optical cable, we have two types of optical cable: overland optical cable and submarine cables. Submarine cables are used to link two countries separated by sea. So there we use underwater cables. They are called submarine cables. Then you have satellite links, microwave links. Then you have your 2G, 3G, this mobility. So all the infrastructure needed for all these things, this is telecommunication infrastructure. So little historical perspective of telecommunication technology development and major services that were available. So it's all started with in 1885. So from 1845 to 1847, when Morse code was invented and the telegram came into picture. So the major services that were there was telegram during this time. Then the first in India, the first telegraph office was established in 1852 by British India that time, and it was in Calcutta. Then 1886, the transatlantic US cable from US to France was put. 1876, the invention of Bell, telephone by Bell. So in 1876, once telephone was invented, but that's telephone you use only copper wires. So the telephones which were there, the telephone came into existence. So it was 1857 when telephone came. Then in 1885, Indian Telegraph Act came, and then we have all other things like in 1870 from London to Bombay, the first Indian cable was laid. Then in India, the telephone came in 1882. That was one first exchange in Calcutta was 50 line exchange was created. So public telephone came in 1882 in India, and so we can say from what we can say is from 1845 to 1885, the major services were telegram and telephone. Then from 1895 to 1982, the major services that we had were telegram, telephone, radio, then TV, and just color TV just arrived, because color TV arrived in India only in 1982. Before that, we had black and white television uh, broadcast. The color TV came in 1982. That was during Asia. So, your 1895, the wireless communication started. 1899, the Marconi demonstrated this your wireless transmitter. That means your radio communication started actually. Then in 1933, India got the Wireless Act. Then electronic switching came in 1995. So once electronic switching came, it was possible to have STD and other things in telephoning, as well as in the meantime, the television also got developed. Then in 1957, the first artificial satellite by USSR, that is Sputnik, was put into orbit, and the communication become further enhanced of wireless communication. Basically, when more microwave and other things came. Then in 1960, the first STD started, that is your subscriber track dialing started from Kanpur to Lucknow. That was 1960. 1974, India launched its first satellite, that was Aryabhata, and first color TV broadcast in 1982. So, from 1895 to 1982, the major services that was provided by Telecom were telegram, telephone, radio, television, which is color, and the meantime, during that time, the cable TV also came. So, in television, the other extension was that is satellite cable TVs, and so the cable TV came into somewhere beyond 82. Then these are your this is, we can say that at present also we have these services. So we have telegram, telephone, radio, TV, black and white, cell phones, direct to home, DTH, satellite phones, pagers, internet. So all these things developed, but they came one after another. So in 1979, the cellular telephony came in Tokyo. And then in 1988, GSM, and that means your GSM standards for mobile phone were adopted in Europe. So from there, we also were part of GSM standards. So we actually took those standards, and within 90s, we had in 90s we had what we call mobile phones or cell phones. Then 1990, the WW, that is your internet, came into thing, and then commercial use of internet started from 1992. And so as these things started, the India also the things went. So in India, your all electronic exchanges, that means by 1984, most of the electronic exchange, your old storages exchange was replaced by electronic exchanges. Then in 1989, we had telecommunication set by Government of India. The commission was set for Telecom Commission. Then 1991, your internet came into civil domain for India. Then 1994, we had the National Telecom Policy launched. And by 1995, the internet services launched in India. So this is how it developed. Then out of all, as the communication developed, also we have more and more services. So out of all the services, to get the services, the most desired telecommunication model. So the most desired telecommunication model is guided or wired long-haul communication. That means the channel infrastructure should be guided and long-haul for long-haul communication. the communication network that can handle communication traffic for long physical distance, such as nationwide, worldwide traffic. And we also call it as backbone network or infrastructure. So for infrastructure, we need our need is guided and wired long haul. The guided here means wired here means not only the metallic wires, but it can be optical fiber. So even optical fibers is wired is supposed to be wired communication. But as a human being, we desire to have information anytime, anywhere, without any limitation. So if you want information anytime, anywhere, without limitations, then we need wireless access. So the most desired telecom model is where you have long haul communication, which is wired. We don't mind that, but the access should be wireless access. So we want wireless access. So hence we can say that the modern telecom provides wireless access to the information globally using wired or guided long-haul communication networks. So this is what is needed from telecom. What we need is we need infrastructure. We should be able to provide wireless access to the information globally. That means it doesn't matter where we are, at what time we are, or anytime, anywhere on Earth, if you're there, you should have access to the global information wirelessly. That is what needed. So our infrastructure needs to be provided to provide you this wireless access to the information. Then in long haul communication, we have basically two mostly used methods for long haul or the global communication. First one is satellite communication. The second one is optical fiber cable networks. In satellite communication, we have normally three kinds of satellites we normally use. And we use microwaves for uplinking and downlinking. And in optical fiber cable networks, we normally use two kinds of cable networks. One is submarine cable network and other one is underground cable network. So we can see those things also. This is for long haul communication or the infrastructure. So this is a satellite. So normally what we do is we use communication satellites, and this is the different components of a satellite. It has a command antenna, it has communication antenna, it has, because satellites are put into the orbit, which is outside the Earth, so it needs to be powered. So it uses solar power to power the satellite. So it has solar cells. And then since it has to function at dark hours also, so during dark hours, it should work with the batteries. So it has batteries inside. Then it has radio transmitter receivers to communicate with us. Then it may have some of its own fuel also kept, especially when it gets shifted from its orbit. It needs to be brought back to the same point where it was. So for that, it may have some motor and some fuels, some thrusters, some thrusting rockets, some cameras, and so this is just a generalized satellite components from inside that normally a communication satellite may have. Then these are the three types of satellites which are used in telecom most commonly. First is low Earth orbital satellite. The satellite orbit is only 600 to 1000 kilometers from the Earth. The second kind of satellites which are used are medium Earth orbits, or LEO, the other one is MEO, and we have GEO. GEO are the geostationary satellites. So geostationary satellites are at 35,786 kilometers from Earth. There exists one orbit only on the equator, where the satellites because satellites need to move in their orbit to stay in the orbit, so that it produces centripetal force, and when this centripetal force produced by satellite, it balances the Earth's gravity, it stays in the same orbit. So there exists only one orbit where satellite can have the speed of rotation around the Earth in synchronous with the revolution of Earth. So if satellite is moving with the same speed as that of the Earth, we call it as geostationary satellite. So geostationary satellites from Earth, if we look at geostationary satellite, we will find it a fixed satellite because it is moving in its orbit in such a manner that its speed is synchronized with the orbit. So geostationary satellites are the most used communication satellites, and one satellite can cover 40% of the entire Earth, and with three satellites we can cover the entire Earth. With three satellites, if we place them at 120 degree to each other, the complete globe can be covered with these satellites for the communication purpose. Then so the most used satellites for long haul communication or in telecom are geostationary satellites. Then the next is your medium orbit, Earth orbit satellites. Their altitude is from around 8,000 to 20,000 kilometers, where we have MEO Earth orbits, and here they are placed in elliptical orbits, and these are normally used for remote sensing uh, and remote tracking and for spying. But the area coverage is large. Then LEO satellites. LEO satellites are the satellites which are actually used for satellite telephoning or satellite phones. But unfortunately, because of your cable, because of your cell phones, the satellite phone didn't become very famous because first of all, their cost was very high, and to maintain maintenance of this, because the companies which invested into satellite phones, almost all of them failed because they couldn't run it. But still, it is being used. Then it has small coverage and short lifespan. So from satellite point of view, for long-haul communication, is normally geostationary satellites are used, and most of the time these geostationary satellites are owned by governments, or some channels can be owned by private companies. But individuals normally can afford to own channels in geostationary satellite. We can use them with the help of service providers, but we cannot own the channels. But normally countries, governments, and big organizations, they can own the channels on the geostationary satellite. Then for optical fiber, the next one long-haul communication is optical fiber. So this is your one optical fiber cable which is shown to you. So the inner we have the fibers. The fibers are as thin as your hair. They are very thin glass fibers, but each fiber can carry, you can say, carry lots of information in the form of light. So these, since these are glass fibers, they tend to be very feeble. So in an optical fiber cable, the more money has to be spent on guarding these fibers than providing these fibers. So fiber themselves are not very expensive. They are not very big. They are very small. But to guard them, we need a lot of things. So that's why you have so many protections provided on optical cable. So you have fiber, which each fiber is there, which carries the information. Then you have unit fiber structures, which is that means you can have different fibers in that structure. Then you have strength wires to give strength to this, because these are glass fibers, so they are very feeble. They can be broken easily. So for giving them, you need the strength wires just to hold them. Then we have a copper sheet to protect it from electrical disturbances. Then we have an insulation jacket. Then above this insulation jacket, you have your armored protection layer. Normally the end of it may be a thick rubber coat. So you have a thick rubber coat. Inside you have some cylindrical wired armors which are used to protect it. So in what we can say in a optical cable, it's normally the protection is much more expensive than the fiber themselves. And so it's written here, and an optical fiber is a hair thin cylindrical fiber of glass or any transparent electrical meter. The function is to guide the visible light or infrared light for long distances. So this is basically optical fiber cables. Then why optical fiber? These are the advantages, because it has a lot of advantage over copper, and that's why the copper cables, they were initially used, but later on it's almost abandoned now. Now it is almost not being used. So OFC is the advantage of OFC is it has a very large transmission. Actually, theoretically, the transmission bandwidth of optical fiber is theoretically supposed to be infinite. That is not because of this is infinite in the sense that today we don't have a technology that can actually use the entire optical fiber. So the electronics technology then is so that's why we can say it's infinite. We can say that the the power loss is very low, and hence it is used for long distance. It has high security because it is inside the armor, so it is highly secure. So it cannot be, we can say it is highly secure. It is immune to electromagnetic interferences because we are surrounded with a lot of microwaves, so it is immune to electrical noises and electromagnetic this thing. Is the capacity of this cable is much higher than copper cable. And the size and cost, space occupied by OFC is very less as compared to copper cable. Since these cables are dielectric, no spark hazards are present. Since it used, because glass itself we know is the insulator, so it cannot have any electrical hazards associated with the OFCs. More corrosion resistant because glass itself doesn't corrode very easily. So more corrosion resistant as compared to copper. Then optical fiber cables have optical cables last longer than copper cables. So because of these advantages, mostly OFCs are used. So the two most used OFCs are underground optical cables, which is shown here, which are put throughout which is being put throughout the country by now even big organizations are putting these underground cables. Reliance is there. You have so many other communication providers which have their own underground cables laid throughout the country. Then we have submarine fiber cables, which are underground, which are undersea cables. And undersea cables, again, the same thing. It has to be protected, and inside you have the fibers. So submarine fiber links. So now we come to the smart cities. So first of all, let's understand why smart cities. So this the first slide that I have. This is basically it is for as per the WHO. In 1960, only 34% world population lived in cities, and 66% in rural. That means in villages. But at present, the world urban population has increased to 55%, and it is continuously growing with a steady phase. That means, and according to the estimates, that means by United Nations, that means by 2050, the 66% of world population will live in urban areas or in cities, which is, you can say, it will be just reversal of what we had in 1960. So within 100 years, this reversal will take place. Like in 1966, most of the world, we had only 34% used to live in city and 66 in rural. By 2050, the 66% will stay. 66% will stay in cities, and 34% will stay in urban or rural. So what we can say from here is more and more people are actually moving towards cities every day. This is what is happening globally. Now, from Indian context, if we look at from the Indian context, then according to 2011 census, Indian urban population was 37 crores, which is around 31% total people lived in cities, and 63% of the national generating 63% of the national economy. The urban population is rapidly increasing, and almost half of the Indian population is projected to live in cities by 2050. So again, in India also, we are having the similar to the global trend. That means more and more people are moving to cities every day in India too. So this is a global phenomena. This is also happening in India. So now consequences of urbanization. Due to the mounting pressure of urbanization, the cities are changing their nature and creating even more divide between expectation of citizens and ability of citizens to deliver the critical infrastructure. Naturally, that you most of you those who have seen the older cities, you will find this problem. That your expectation from city is very large, like say it is happening in Delhi as well as in Bombay during rainy season. You have every nook and corner of the cities get flooded because the population has grown very large. Not many people have come with illegal kind of constructions, and many more. The cities are trying to support much more than the people they actually can support. They are designed to support. So these are the problems that happens because of urbanization, the population growth, aging infrastructure, limited resource, changing need and expectations of the city creates new challenges for city to tackle. As cities, but again, since cities are becoming more and more attractive place to live, work, and visit, these are intended consequences and impact. As a result, increased demand in their infrastructure. So because of urbanization, there is an increased demand in modernization of the infrastructure. So now what is the solution? So solution is to handle this large scale urbanization, we need to find new ways to manage complexities, increase efficiencies, reduce expenses, improve quality of life, and this will lead to manage cities in a smarter way. This is thing. With the emerging technologies, with ultra-low power sensors and wireless networks, web and the mobile application, smart city are becoming a reality. So smart city focuses on the most pressing need, that the greater opportunities to improve quality of life of the resident today and in future. So basically, the problem is urbanization and the solution is smart city. Where we create all the infrastructure, everything smarter. The smartness of the city is determined by, we'll see it by the telecommunication facilities which are provided. So we will see that very slowly. Let's understand smart cities first. So the concept of smart city is this is little history. That means the concept was born in 1994. So it's not a very old concept, the smart city was born in 1994 when smart city was used for first time. And due to the relevance, there's a lot of work went into smart cities. So because of the relevance of smart cities, it is also referred by many related terms like cyber village, digital city, electronic city, telecity, information city, intelligent city, knowledge-based city, ubiquitous cities, and wired cities. So all these are all what we can say synonyms of smart cities. Out of all these synonyms, two were mostly used. One was digital city and other was smart cities. So till 2010, digital city was more used. So literature digital city was more used till 2010. But from 2010 onwards, the smart city was most frequently used for the concept of smart city. So the definition of smart city, there were many definitions given. I'm just providing some of them here. So the first definition, which came in 2000, and a city that monitors and integrate conditions of all its critical infrastructure, including roads, bridges, tunnels, railways, subways, airways, air, seaports, communication, water, power, even the major buildings, can better optimize the resources, plan its preventive maintenance activities, and monitor security aspects while maximizing the services to the citizen. So this was one of the definition. Then the other definition came, smart city is a city, well-performing city built on a smart combination of environment and activities of self-decisive, independent and aware citizens. So this was another definition. Third definition was a city to be smart when investment in human and social capital and traditional, that is a traditional and modern ICT communication infrastructure fuel sustainable economic growth and a high quality life with, with a wise management and natural resources through participatory governance. So this was another definition for smart city. Then similarly, you had another definition. I like this one-liner, that is smart city is a product of digital city combined with Internet of Things. This was another definition, but it's a smart definition. Then you have this is smart. This is smart city is well-defined geographical area of high technologies such as ICT, logistic, energy production, and so on. Cooperate to create benefits for the citizen in terms of well-being, inclusion, and participation, environmental quality, intelligent development. It is governed by well-defined pool of subjects able to state the rules and policies of the city government and development. And the sixth definition, this is the standard or internationally accepted definition. This is a definition given by ITU. So ITU, that is your International Telecom Union. So it is telecom people, those who have given this definition. And now this is one of the most used definition or internationally accepted definition for smart city. So it says that a smart, sustainable city is an innovative city that uses information and communication technologies, that is ICTs, and other means to improve the quality of life, efficiency of urban operation and services, and competitiveness while ensuring that meets the needs of present and future generation with respect to economic, social, environmental, as well as cultural aspects. So this is your standard definition. So I put the standard definition once again in the next slide. So you have now the feel of a smart city. So smart city is what we can say is different components that we have in a smart city. So you have in different components that we have in smart city, we have this is your smart city, which is defined as by the previous definition. So it may have smart agriculture, smart homes, smart education, smart energy, smart governance, smart health, smart mobility, and smart retail. So the components that are normally used, these are some of the components which actually talks about the smartness of city. The smartness comes from ICT. That is your basically the information communication technologies which are used in the. So you have smart infrastructure, smart transportation, smart energy, smart healthcare, smart governance, and using smart technologies for smart citizens, because ultimately these cities are for citizens. So if your citizens are not getting the benefit out of it, it's of no use having the cities. So having all this smart but for the citizen. So you have even the citizens, you can have smart citizens. The components are what makes the city smart and efficient using information communication technology. So ICT is the enabling key information for the traditional cities. So we can say if traditional cities develop ICT, they can also become smart cities. So it is slowly being used, even all the cities. So many cities are in India which are declared as smart cities. They are slowly going to adopt all these smart infrastructure, smart transportation, smart energy, smart healthcare, and smart governance. And then they will become smart cities. So these are your different, we can say, the characteristics of smart city. So first we have components, then we have attributes, then we have themes, then we have infrastructures. In components we have infrastructure, so smart infrastructure, smart buildings, transportation, smart energy, smart healthcare, smart technology, smart governance, smart education, and smart cities. That is your components. Then the attributes we have sustainability, whether whatever we are providing they are sustainable by themselves. That is sustainability. So these attributes are normally they will be used to judge the smartness of these cities. Then these sustainability, then quality of life, whether it has improved, then urbanization, how much, then the smartness, how smart. Then similarly, the themes you have society, you have economic themes, environmental themes, and governance themes. Then the infrastructures, we need physical infrastructure, we need ICT infrastructure, and physical and ICT infrastructure together will provide you the services. So these are the components and the characteristics of smart cities. Then this is your those components again, smart infrastructure, smart. So we'll see these all these components one by one. What exactly is these? So we have all these components here: smart infrastructure, smart buildings, smart transportation, smart energy, smart healthcare, smart technologies, and smart governance, and all connected to each other through ICT. That means you have ICT technologies which makes them connected. Now, how it is done, we will see that also. So let's first see these components one by one. So first, the infrastructure. So in the infrastructure, we have the infrastructure needed is rapid and fast transit system, waste management system, road networks, rail networks, communication network, traffic light systems, street light systems, official space, water supply system, gas supply systems, power supply systems, firefighting system, hospital system, bridges, apartments, hotels, libraries, and law enforcement and economic system. So these are the physical systems for which the infrastructure need to be provided. So the infrastructure for say business, you need factories, offices, data centers, and so many things. Then for all this, we will have a code network of ICT, which will be connecting all of them together. Then in public infrastructure, we will have transportation energies, because slowly we may move from petrol to electrical. So you will have electric charging points and so many other things. Then then you have energy management system, where you have electricity, your electricity billing, all those things will be done almost automatically by using smartphones, smart meters, and smart things. So the back end of the smart infrastructure is the ICT. That is, we'll see under what is information coverage, your technology, which makes the physical infrastructure smart. So this is smart infrastructure that is needed to build smart cities. The smart transportation. So in smart transportation, we can have all kind of transportation. You can have sea transportation. You can have by air transportation. You can have roads. You can have uh, railway lines, and and required infrastructure for all these things, and that too in a smarter way. So the smart transportation is also known as ITS, which is your intelligent transport system. ITS is intelligent transport systems, including various type of communications, navigation systems. So you will have communication systems as well as your navigation systems uh, in vehicles, between the vehicles. That means navigation in vehicle, between the vehicles, between vehicle and the fixed locations, that is car to infrastructure. Smart transportation systems allow passengers to easily select different transportation options for at the lowest cost and the shortest distance or the fastest route. So however you want to travel, you can have that choice, and accordingly you can select appropriate transportation system. And this transportation system will become part of the city, making it smart. So the smart transportation. Then smart energy. So in smart energy, basically the smart energy system consists of intelligent integration of decentralized sustained energy sources, efficient distribution, optimized power consumptions, in essence, and traditional energy, green energy, sustainable energy, and renewable energy, along with the ICT makes it smart energy. So the system shown here, so smart energy, you have a low carbon generations production. That means by you can have wind production, windmills. You can use solar photovoltaic production, hydroelectricity, or biomass. So these are low carbon generation. Even the nuclear is supposed to be low carbon generation, but only thing is since it is hazardous, normally it is not used near cities. So because it can always give a disaster. Then you have efficient distribution, where you have infrastructure for what we call it as smart grids, and all can get the energy. Then the energy trading. Energy trading is depending upon my demand. I can there can be a flexible cost of the energy. So at high demand time, energy may be costly for people to buy, and low demand time energy may become cheaper, and you can buy more energy at a lesser cost. Then direct marketing, and then using information technology. And similarly, you have energy management, uh, energy mobility, intelligent devices, energy storage, and smart metering. So all these become part of the smart energy. So there is so this here you can say right now actually at present the DC networks are, if you see, you have AC and DC, both are shown here. At present, all the power distribution that we have is AC. That means the consumer normally get the AC power. But we may have, once your electric cars and electrical vehicles come into picture, then we will also have our DC network. So here it is shown with the rectifier, our DC network, which is used for charging. So this may be provided throughout the cities for electric charging of the electric cars. Once electric cars become more and more usable, and more people use electric vehicle, and within the next 4 to 5 years, this may happen. Within the next 5 years, it may happen that people will have more number of options to buy more electric cars, battery electric cars, cheaper electrical car, and then definitely the fuel consumption is cheapest as far as the electrical car is concerned. So, so this is smart energy. Then we have smart healthcare. Now, in smart healthcare is basically when health is available to an individual. So, the best way I can tell you about a connected system. So, you have a smart hospital, you have a smart emergency response, or your smart home, smart infrastructure, smart gadgets. You also may have robots serving you in the hospital, on-body sensors. You have also the healthcare, smart hospital, nurses, doctors, and all connected by using cyber physical systems or ICT. That means like if a patient is even at home, if we put him some body sensors, his all the information that is generating like pulse rate, its heart its heart condition, its ECG, its other conditions, your oxygen level, and all those things, they can be directly transmitted to the doctor, and doctor can take a decision just from there what to be done, and can tell the people at home that what is needed. So this kind of infrastructure will be available for the smart healthcare, and the smart cities will be using smart healthcare. But again, smart healthcare is only possible if we use uh, ICT or the cyber physical systems or IoT. So let's see this is the this is the actual what I'm supposed to give you. The already there are 7 ICT pillars which are identified for smart cities infrastructure. So these ICT pillars which are identified for smart city infrastructure, these are here. So these are shown on this diagram, which is shown here on this diagram, and with red they are marked as 1, 2, 3, 4, 5, 6, and 7. So we will see all of them one by one. So the first one is integrated management system, or we also call it command and control system. So this is your first one. Then the second ICT is your public services and applications, which are provided. Then and all these applications, they will have a physical infrastructure, social infrastructure, institutional infrastructure, and economic infrastructure to be provided. Then we have, so we will see them one by one. So as and when we will be talking, I will come back to this this ICT pillars of smart city. I'll come back and then I'll go come back between these things. So let's start with the first one. The 7 identified ICT pillars are, first one is integrated management and command center, which is shown here. So then the second one we have is services and applications across the various verticals. Then third one we have is communication networks. Fourth one is devices and chipsets. Fifth one is data. Now data is divided into 2 types, data 1 and data 2. So we'll see this data 1 and data 2, what exactly it is. Then we have city assistance tools. Then we have information and digital security. So we'll talk about all of them one by one. So let's start with the first one, the integrated management and command center. So integrated management and command center, this will provide a single interface to view all the integrated city level information. These command centers do not imply that only one will be applicable to a city, but many smaller ones could feed requisite information along its. Yes. Hello. Hello. Am I audible?
Yes, sir. Yes, sir. Actually, someone mic was unmuted. I have muted it.
Okay. So integrated management and command center. So this will be the heart of your smart city, or this will be a control room. And that doesn't mean that it may be just one in the city. You can have a different, like something like, say, right now, you have a main exchange and you have a many number of small other exchanges all around in the city. From the main exchange, you can control most of the all outer exchanges. So this will be the place which normally may belong to your municipality, and which will have displays and other things which will be telling you almost everything about what is going for, like it will have a control center for all the cable TVs that you are using, and their monitors will be there where the things can be seen. It may have a huge display of current traffic with the complete traffic conditions can be seen from there, and so many other things. So this will be more or less a command and control center for the city. But again, it need not be just one. It can be n number, but all integrated together, so that we know exactly what is happening in different parts of the cities at that same time, for providing better services and better things. So this is your first component of ICT, or the first pillar, which is the one. So it will have visualization, where you have displays, you can see. Then it will have dashboards, integrated operational centers, and command and control. So that will be your integrated management or command and control. The second will be the services and applications across the various verticals. So these are the different services, and which a city, the city infrastructure is supposed to provide. Smart mobility, that is your intelligent transport systems. Vehicle telemetry. Vehicle telemetry means basically where your vehicle is right now, where it is going to be, and all those data will be available. That is vehicle telemetry. That is, suppose you have a car, and or you are moving in a taxi, and you want to know where you are, you can get that information also, or telemetric information, or which is geo, basically your geographical GI information, geographical information. Then your insurance, car insurance, your fleet management, connected cars, all these things will be in smart mobility. Then smart healthcare, all connected smart healthcare. That we have already talked about all these things. Then smart living, that is home automation. Smart utilities, that gas, water, electricity, all will be smartly used. Smart governance, the software solutions that can be used by various departments for smart governance. Like at present, as this for the government has used your vaccination. That means now that means this time we have used the biggest possible database, that almost everybody who got vaccinated, we have its data with us. So that kind of system, that is smart governance. Then you have smart manufacturing, and the predictive maintenance. That means maintenance before it fails. That's predictive maintenance. That means if you have devices which can tell you about their own health, then we can go for predictive maintenance. Nowadays it is possible, because say you have a motor finally fails. Normally it always starts with some vibrations. So first it will vibrate for quite some days. It will keep on vibrating at certain frequencies, and after that it will fail. So as soon as if I put a sensor on this kind of motor, then as soon as this vibration goes beyond a level, I know that my motor needs maintenance. So before it actually fails, I can maintain it. So this kind of system, this is preventive maintenance. Then smart safety and security is basically CCTV surveillance and monitoring, and all other security, because there is a different kind of security which also need to be provided. We'll see that also. Then we have communication networks, and these communication networks are the backbone of ICT. So the communication network technologies provide the infrastructure for the smart cities to make all the devices, computer, people, have convenient, reliable, selective communication path with each other. So this includes wired networks, wireless networks, satellite networks, transmission protocols, which is M2M connectivities, networks that can be called WAN, PAN, LAN, MAN, WAN, GAN, which already I told you. Then dedicated resources that could be allocated for critical communication and during the emergencies and disaster. So these are the communication networks. Then devices and chips. Now to provide all these networks, we need some devices and some chipsets. So devices that are normally used in computer networks or in networks, we need routers, we need computers, and we need other networking equipment, because ultimately this will be the network of things, or what we call it as Internet of Things, IoT. We'll come to that also. And then M2M is machine-to-machine communication will dominate, because most of these connected devices, we need them autonomous. And if they are autonomous, that means they need to communicate with each other. So we have machine-to-machine communication protocol, which is used, and so the in M2M communication dominate. We use devices like sensors, RFID tags, chipsets. You have mobile devices, embedded softwares, and the facilities to form sensor web, or what we call it as WSN, or wireless sensor network. So normally these wireless sensor networks will be the used to take the information and then put it through the network, and from there we extract the whatever the outputs we want to extract from the information that is being generated by these sensors. It is something like you have, say, wire sensors, and put in a building, all across the building you have fire sensors. And as soon as one of the sensors senses the fire, it will alarm the entire building that there is a fire at one place, and a decision depending upon that can be taken. But again, suppose you that there was a false alarm, say because of somebody was smoking in the building, and the sensor took it to be a fire, but false alarm. So we should have a system where we can have some other way so that we can avoid this kind of false alarm. So all these things makes your sensors smarter.
How many class? How many class?
Then we have data. Now data, as I told you, we have two datas, data 1 and data 2. So actually what this data 1 and data 2 is, first one is the data that people will be using. And the second one is what we call is open data, which will be generated when the people are using different services. So this generated data, we call it under open data analytics, where we can do the analysis on it and then make better decisions. So data 2 will be the analytics part. Data 1 is your data that is, so data 1 will be your data centers, cloud, analytics, backend platform infrastructures. So cloud computing is derived from computing or the storage. That means different computing services, storage services, and on machine-to-machine platform which will be provided. So data, we can say in data 1 will be data as a service. So like
Vivek sir.
Yes, ma'am.
I think sir has left.
Sir has left.
Maybe
I think.
some network.
Yes. Yes, ma'am. I was also searching it, but sir is not there, I think. Let's wait for some minutes.
Indrani,
Yes, sir.
वो सर का फोन आया था कि वहाँ कुछ पावर प्रॉब्लम है, तो तुम यहाँ से उनका मतलब कहना चाहिए वो शेयर कर दो प्रेजेंटेशन एंड ही विल ज्वाइन ऑन मोबाइल,
ओके
है ना।
ओके सर।
उनका प्रेजेंटेशन जो है यहाँ से शेयर कर दो,
हाँ ठीक है सर, एक मिनट मुझे।
हाँ, और उनसे बात कर लो, वो मोबाइल से जुड़ जाएंगे, मेरी बात हुई है अभी।
ठीक है सर।
हाँ
तो शेयर कर दें क्या सर?
हाँ, कर दो कर दो।
इज इट विजिबल?
अभी आया नहीं, आने दीजिए।
विजिबल?
अभी अभी नहीं दिख रहा है।
विवेक सर, अभी नहीं दिख रहा सर, एक सेकेंड में फिर से। नाउ सर, इज इट विजिबल नाउ?
नहीं, नहीं आ रहा है।
सर विवेक सर, मैं आपको व्हाट्सएप कर दूं क्या वो पीपीटी? विवेक सर,
हाँ यस मैम।
हाँ मैंने आपको पीपीटी व्हाट्सएप किया है, प्लीज चेक।
ओके।
उस पीपीटी को शेयर कर दो विवेक,
जी
एंड
सर।
he'll join on मोबाइल एक्चुअली है। वहाँ
ओके।
कुछ पावर फेलियर हो गया है, तो बोले कि थोड़ा सा प्रॉब्लम हो रहा है इस तरफ से।
हाँ 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 बिल्कुल सर। मेरा स्क्रीन विजिबल हुआ क्या?
यस सर, विजिबल है।
ओके। और फुल स्क्रीन में आ रहा है क्या मैम, या?
नहीं, फुल स्क्रीन नहीं दिखा रहा सर।
अच्छा, सिर्फ पीपीटी दिख रहा है। ओके। ओके। सो सर सर ज्वाइन हो गए क्या?
नाउ इट्स कमिंग।
हाँ ये सर, मैं तो कर दिया हूँ, लेकिन सर हैं क्या?
सर से बात कर लो ना फोन लगा के, सर
अच्छा।
वो मोबाइल पे जुड़ जाऊंगा बोले, उनको बता दो।
ओके।
मैं लगा लेती हूँ सर।
हाँ हाँ
हाँ,
जी।
बता दो। क्या हुआ इंद्राणी, बात हुई?
हाँ सर, वो ऐड हो रहे हैं सर अभी।
हाँ ठीक है।
जी।
क्या हो गया है? कौन भिजवाया? किसने बोला है? प्रजापति मैं वापिस किया था ना अभी।
हेलो,
कौन दिया आपको?
मेरे को पिछले बार।
हाँ, इसकी नोट शीट कहाँ है? हाँ, ये मैं बोला ना कि ये इसमें मैं कमेंट नहीं करूंगा, जाके बता दो प्रिंसिपल साहब को।
हेलो,
पता है फिर भी मतलब कहना चाहिए, इसको बोलो उसको बोलो।
हेलो।
हाँ रघुवंशी साहब,
हाँ सर।
now your slides are displaying here, so you can continue.
अच्छा, ये सर स्लाइड का अभी कौन, मेरे को तो स्लाइड दिख नहीं रहा है।
आपको नहीं दिख रहा है सर?
हाँ।
ये स्मार्ट ट्रांसपोर्टेशन वाला स्लाइड है इसमें भी।
अच्छा,
स्लाइड नंबर 29, 28.
actually I'm not able to see the slide.
Okay.
तो नेटवर्क इशू हो सकता है सर।
अच्छा, मेरे को तो पता ही नहीं चल रहा है, मतलब आई एम ओनली एबल टू सी माई सेल्फ। मैं तो एक्चुअली मोबाइल में फर्स्ट टाइम यूज कर रहा हूँ, मैं नॉर्मली अपने लैपटॉप से ही करता हूँ। और हमारा नेटवर्क भी डाउन हो गया बिकॉज पावर ही चली गई, बहुत तेज बारिश हुई और पावर चली गई।
ठीक है सर, तो यहीं वाइंड अप करते हैं।
आ
सर
गया
एक
सर,
बार
आ
फिर
गया, आ
से
गया,
शेयर कर रहे हैं,
आ गया।
आप
अच्छा,
एक बार देख।
आ गया मैडम, मैडम आ गया, वो
ओके
स्लाइड आ गया।
आ गया, ओके सर।
ओके ओके।
अभी इससे अगला स्लाइड के लिए ये सब कवर कर दिया मैंने।
हाँ हाँ, नेक्स्ट कर दो
हाँ।
इंद्राणी।
हाँ यस सर, वो विवेक सर कर रहे हैं।
हाँ विवेक। हाँ
हाँ
यस
ये
यस,
सर।
दिस इज स्मार्ट एनर्जी।
हाँ, स्मार्ट, ये भी इससे भी आगे। अब नेक्स्ट ये कर चुका हूँ सर, मैं ये कंप्लीट कर चुका हूँ। हाँ,
अच्छा
दिस वाज द लास्ट।
ओके।
ओके, द स्मार्ट हेल्थ केयर, दिस आल्सो डन। नाउ द नेक्स्ट वन देयर इज, आई विल स्टार्ट विद। ओके, एम आई ऑडिबल?
यस सर, यस सर।
ये जो आईसीटी पिलर्स भी, ये मैंने लास्ट वाले में ले जाइए, ये भी साथ कंप्लीट कर दिए मैंने।
Okay.
All 7 pillars. Next up to ऊपर नंबर आता रहेगा 1 2 3 4 7 तक जाएगा.
Yes sir.
ये भी completed. Completed. हाँ बस ये वाला.
Okay, sorry. It's a formal definition of IoT.
हाँ please sir. That's right. IoT. So this is now to have everything smart, we need IoT or Internet of Things. So these are the different definitions which are given, formal definitions given to the IoT. So IEEE definition is which is given is a network of items, each embedded with sensors which are connected to the internet. So this is your IEEE definition. Then we have ITU definition, and similarly we have IEFT definitions. So these definitions are already there, so you can just read them up, and I'll just come to the diagram next, where I can explain you these things. Okay, so this is your basically the internationally accepted definition of IoT. A global infrastructure for information society enabling advanced services by interconnecting physical and virtual things based on existing and everything interoperable information communication technologies. So basically IoT is Internet of Things, where you have anything which can be connected actually onto the net. So you have homes, which you have other technologies, and like in a smart home, you may have a refrigerator, you may have a washing machine, you may have a printer, you may have a computer, and all these can be controlled, as well as we can get information from them. Like says you have a washing machine and you have put your clothes there, then after the clothes are washed, the washing machine, you can instruct from your office itself for the washing machine to shut it out, and that kind of thing is possible with IoTs. So next step, madam. Next.
Yes.
Okay, so this is your this is a timeline evolution of IoT. It started from your Internet of Madam, can you make it full screen, because I'm finding very difficult to see on this small screen.
Sure, sir. 1 minute, just a minute. Is it fine, sir?
Yeah, it's fine. So you have initially the initial state of internet was human to human. Then WW came. Then we had Web 2. Then we have a social, and then now it is what we have IoT or Internet of Things. So it's basically initially more communication between humans. That was point-to-point communication was there, more like email and all those things. Then came your other thing where more information like entertainment, you have movies and all those things being explained, been distributed and used with WWW, World Wide Web. And then came the social networks, where you have Twitter, Facebook, other things where you can have multicasting. And now it is the same internet can be used from machine to machine, that is M2M network, and there is where you have IoTs, and it is here where we will have the smartness of our cities and other things. Next, please. So these are the your different layers of IoT. The bottommost layer, we have devices. Actually, we have at the bottommost layer we have devices, and where we have sensor networks, where you have network sensors, where we just gather the data. Then your second layer is the network layer. First one is your physical layer, which is composed of wireless sensors and wireless sensor networks, where we gather the data. Second one is the network layer. The network normally it is your internet internet layer, where this data can be transported, and with internet advantage is the data becomes global. That means the data that you have can be seen from anywhere, any time. Then above that we have support. The support is basically you have a support where with what we call intelligent computing, where this data can be analyzed. And the fourth layer is your application, where we can extract the information from the data and we can use it for the human purpose. So these are the four conceptual layers of IoT. Then next, please. Next, please.
Yes, sir. I have done it. Next. Uh,
Okay, so next, this is all theory. You can read it. I'll just come to the next one, more important ones. These are to defining the IoTs, how we define IoTs. Then so so this is the scope of IoTs. The scope of IoT is not limited to just connecting things. It allows to connect things to communicate and exchange data by analyzing and processing the raw data. The information can be extracted, which can be used and take information and to take information wise decisions. So this is informed and wise decisions. So that is your basic need. Then depend upon the field of application, processing on these data will provide in numerous applications, making smartphones, smart cities, smart agriculture, and smart everything with the help of IoT. So next, please. This is the scope of IoT. So then to implement IoT, we need machine to machine, which is M2M. So because your this slide just says because your number of machines connected are slowly, the communication between the machine is more than human to machine to human. So M2M protocol. And so M2M refers to the technology that allowed wired and wireless systems to communicate with devices with the same abilities automatically. So this is machine to machine. So next, please. Next. Okay, so this is your generic machine-to-machine architecture. So you have M2M devices, which I told you as networks, which you can see at the end. These are wireless sensor networks, which generates the data. Then you have next one is your network domain, which carries the data, and the interface between the generated data and the one data being carried is a gateway. So you have M2M gateway, which allows the generated information to run over the network. And then you have the last layer, which is your application domain, where the intelligent decisions can be taken depending upon the analysis that is done on the data. So this is your generic M2M architecture. So data here is generated, and data here is generated, or other way we can say collected by the network of sensors which is there at the your devices. That is first domain, and then this data is carried on to the network. So mostly your this carrying through a gateway, and then it is goes to a processor where the processing can be done, and we can extract the information from the collected data, and that information can be used at the application layer to take smart decisions. So this is a generic M2M architecture. Next, please. So these are the technologies which enables M2M communication. You have wireless sensor network, RFIDs, mobile internet, wire and wireless communication network, IPv6, IPv4, information gathering personal area network, that is PAN, then home area network, HAN, local area network, LAN, and field area network, FAN. The low power wireless communication technologies like Wi-Fi, Zigbee, 6 low power PAN, that is low power personal area network, then Bluetooth technologies, Z waves. So these are the technologies which enables these devices, that is your to get the information. Then in the networking or the communication part, we have GSM, 3G, 4G, 5G, fixed satellite broadcast, FTTH, that is your fiber to home, and it may be used for connecting M2M gateway to the servers. Then low power wide area network, low technologies such as LoRa and SynFox may be used for transmitting very small data over long ranges based upon your GPP releases. Next, please. Okay, so this is the your IoT domain which is shown. So we have a long haul communication which will be provided by fibers. You have satellite communication. You have other devices, and all these devices they communicate with each other. And most of the technologies which are used are also named there. So like for surveillance, we have different technologies for communication and all these things. So this is a generic diagram which gives you the M2M or IoT domain. Next please, because next one is your that is more of concluding, which will have all these things again. So okay, so this is actually distance-wise different technologies which are used to implement IoTs. So distance, on one axis we have the distance. So that is distance, or the you can see the proximity. Proximity is when you are very near to the device. You have your proximity. Then you have as your distance increases. So you can say first one is within 10. The proximity is up to 10 meters. Then from 10 to 100 meters. Then beyond 100 meters. And that way you have different. So you have these circles. These are increasing diameter. So for the proximity we have WSN and RFID. These are the devices which will be used for the proximity, and the networks that we will have in the proximity are BAN, that is your body area network, which will these sensors and all this thing attached there, they will be giving information, and mostly this information will be then given over to the by using personal area network, that is wireless personal area network, and where you may have Bluetooth. So these are the technologies. Now out of this, some are black and some are red. The black ones are the technologies which can be used there, and the red ones are the one which are being used. So you have like Zigbee, the all these are being used. You have uh, 802.11 PAN and this. So similarly, like you have this 802.11P, which is being used right now. This is your wireless LAN. So the next will be your wireless LAN applications. Then beyond that, you have neighborhood area networks or the wireless neighbor area networks where you have LoRa and Zigbees that is your being used. Then you have a long area network which will use the cellular technologies in out of which LTE is the most used technologies right now. Then you have LoRa and you have PTC. So these are the Sigfox. These are the long distance technologies which are used. And so all these technologies, they are, some of them are developed, they are mature, being used. Others are still developing and will be used. So next one, please. Hello.
Yes, sir.
Uh, okay. So wireless access network is, so this is a cellular network of the radio network which distributed over the area called cells. So your wireless access network is normally done with the cellular network. So we can this is so although it is invented, and it's actually the commercial use came in 1979. So let's come to the next one. Wireless access networks. Next slide, please. Okay, so this is your cellular network where you have a cell phone, then you have base BCS, BSC. That is your so the how your cell phone get connected to the nearest transmitter, and this transmitter is connected to the your station. There is a basic station, and then from there it goes to the MSC, which is your switching center, mobile switching center. The mobile switching center switches it to the other mobile, and that is how we communicate in a cellular network. So in smart cities, this is the general cellular network. So in smart cities, the next slide, please.
Yes, sir.
Okay, so these are the different generations of mobile technology or cell technologies. So you have 1G, 2G, 3G, 4G, 5G, and 6G. So right now we are having 5G is available, but it is not yet fully covering the our system up to 4G. 4G is available throughout the country now, and 1G, 2G. Actually, 1G never came to India. We started with almost 2G and 3G. We almost started with 3G actually. The 2G was just dying off, and 3G has just come. Then 3G is one of the most used technology as far as our is used. So this tables gives you different for all these technologies. 4G is which uses CDMA. This this technology is basically, as we go from one technology to another, it is services they get better and better. Like in 1G was only phone, 2G was text messages and phone, 3G was text message, phone, and the graphic messaging or the video were able to send. In 4G, we can have what we call in 4G we can have this video calls, and 5G we can have instantaneous video call. That is basically we can have video on run. That means as you are going around, there will be no hindrance for continuity in your video call. So that way this is, and 6G is still on the board, and it is being developed. Okay, next please. So these are the future technologies. So you have 5G. Already I talked about it. 5G, you can read it, and because this is no point just I will be reading one by one the points. Since these are available to you, you can always read them. So in these are the 5G provides large broadcasting data in gigabits. Then this is the 6G. 6G is integrate these kind of satellite networks to provide network positioning, identifier, multimedia, and internet connectivity, and weather information services to the mobile users. Data rates up to 10 to 11 Gbps. So since data rates are so high, even you can have mobile streaming. You can have mobile streaming. Then may be used for the production of energy from the galactic worlds. Home automation, space technology, defense applications will be modified with the 6G networks. Then satellite to satellite communication will also be possible. So these are your future for 6G. Next, please. So this is of optical fibers. So these are right now we have BharatNet, which is providing these networks. This is Bharat Broadband Network, or we call it BharatNet, and which provides this. So you can just read it and you can find out what are the. So we have 250,000 gram panchayats of the country, covering area of 625,000 villages, are utilizing on existing fiber networks, and we are extending it for every panchayat. So to achieve this, Bharat, what we call it BharatNet, or simply Bharat Broadband Network, which was established on 25th February 2012 under Companies Act 1956. So 16 states and all union territories MOU with 26 October 12 was signed, and we have 1,40,727 gram panchayats will be facilitated with optical fiber networks. Next, please. Optical fiber used in India as infrastructure. So this is the present optical infrastructure in India. That means Indian OFC is the OFC market will be around 2.1 billion by 2024. Then moreover, growing demand of OFC, the IT and telecom sector, the existing number of mobile devices are increasing because FTTH has come. The connectivity and surging number of data centers are further anticipated to fuel the optical fiber cable market in India over the coming years. So this is about present optical infrastructure in India. So this is the current status of BharatNet. That means Government of India has approved setting up national optical fiber in 2012 and under UPA government. Later on, it was named as BharatNet. The World Bank study has estimated that 10% increase of broadband connectivity leads to 1.2 0.38 increase in the gross domestic product. So broadband penetration in India at present is less than 2%, but it is need to be improved. Next, please. So this is BharatNet as that I was talking to you, which is taking care of this. So next, please. So these are your status of BharatNet. So it has phase one. Then you have the right now it is your GP. So this is basically GP here is Gram Panchayat. So the phase one we had 1 lakh Gram Panchayat. So that was phase one was connected to 1 lakh phase one, which is completed, and then implemented through these are the different agencies which implement the BharatNet. So existing fiber of BSNL between blocks to Gram Panchayat is used to lay and connect new access under this project. So this is the next slide will tell you about next slide. So this is your as on October 2020, that was the status. So you can just go through it by different agencies, and each of them has. So we are quite doing quite well as far as it is. So today's what we can say is on 2nd October 2020, the total length laid is already 4,59,124 kilometers of fiber is already laid in our country. Number of gram panchayats are around 1,57,624 gram panchayats are already there, and out of which 1,45,545 gram panchayats are already connected. So we are quite good as far as this goes. Then in submarine cable, actually in India we don't have much of the country connected through sea. We are only connected to other countries through sea. Only 2 or 3 places are there which are connected by sea. Something like Andaman Nicobar, which from India we can have a connection. So very recently we have connected Andaman Nicobar with the submarine fiber links. So can you come to the next one, which is there. So this is the fiber link which is laid. You have 2 connections, one from Chennai to Andaman Nicobar, and other one is from Calcutta to Andaman Nicobar. So all telecom operators in the country will be able to provide their mobile and broadcast services because of this optical link. And Airtel is first to launch ultra-fast 4G services in Andaman and Nicobar. So Andaman Nicobar also now connected through submarine cable. So submarine cable is laid. So this is a diagram here which gives you. So it has 2 connections. So right now this Chennai to Andaman one is established. Calcutta to Andaman is under construction. Next, please. So these are the references. So you can go through them. So next, please. These are more references. There are total 30 references are there. Okay, thank you very much. And I'm sorry for last part of my presentation because of power failure. I couldn't present this as well as I might have presented. I'm sorry for that. Anyway, thank you very much. Any questions, please?
Thank you, sir. You rightly focused on the topic and explained with great expertise. So now I request all the participants to join the discussion. You can raise your hands or you can post questions in WhatsApp group. So we will take 1 or 2 questions so that we can wrap up on time. If there is any query. So I do not find any raise hand or any question.
Okay, if you have any questions, you can send it and send it to the coordinators, and they can mail me up. I can give your answers.
Yes, sir. Yes,
Personal mails also.
yes, sir. Yes.
Okay, then thank you very much.
Thank you, sir. Thank you so much. So with that,